Hello and welcome to today's ACM SIGSOFT webinar. This webcast is part of ACM SIGSOFT's commitment to provide value to its current and future members. The ACM SIGSOFT webinar series features speakers from the Future of Software Engineering track at the International Conference of Software Engineering, as well as select keynote speakers and distinguished paper authors. I'm Robert Dyer, Assistant Professor at Bowling Green State University and member of the SIGSOFT Executive Committee, and it's my pleasure to welcome you today. Before we get started, I'd like to quickly mention a few housekeeping items shown on the slide in front of you. First, notice the URL for a short two-question poll. Please fill this out now if you have time. The slides will advance automatically throughout the event. On the bottom panel, you'll find a number of additional widgets and resources. If you're experiencing problems with the slides or audio, press the F5 key in Windows, Command R on a Mac, or refresh your browser on mobile devices, or you can close and relaunch the presentation. Control volume, adjust the master volume on your computer. If you have questions during the webinar, please type them into the Q&A box at any time during the webinar and click the Submit button. At the end of the presentation, we will have time to respond to the questions. This session is being recorded and will be archived. You will receive an automatic email notification when it becomes available. Today's presentation is The Changing Landscape of Refactoring Research in the Last Decade by Danny Digg. Danny Digg is an Associate Professor of Computer Science at Oregon State University and an Adjunct Professor at the University of Illinois. He enjoys software engineering research with a focus on interactive program transformations that improve programmer productivity and software quality. He successfully pioneered interactive program transformations by opening the field of refactoring in cutting-edge domains including mobile, concurrency and parallelism, component-based, testing, and end-user programming. He has received numerous awards, including the NSF Career Award, the Google Faculty Research Award, and the Microsoft Software Engineering Innovation Award. He's released 9 software systems, among them the world's first open-source refactoring tool. Some of the techniques he developed are currently shipping with the official release of the popular Eclipse, NetBeans, and Visual Studio development environments. Danny, without further ado, take it away.
Hey, Robert, I appreciate you for introducing me and for hosting these calls, which provide so much value to our computing field. And I've listened myself to a few of these excellent ACM SIGSOFT webinars in the past. They are excellent. So I'm honored for being invited and to speak with everyone today and being on a list of such distinguished speakers that we've had in this series. And I'm very excited to be here today. With all the audience, I've been looking forward to this moment for weeks, and I woke up early this morning, and it was about 5 a.m. I was thinking about all of you here on the audience, and I was so excited. I wanted to call Robert and say, hey, can we get an early start, because I prepared new material, especially designed for you based on feedback I got from Robert earlier this week about the audience and about your needs and your desire to grow and as a community. So I subtitled my talk, Refactoring the Refactoring, because I will speak about some of the big changes that we have seen in the field of refactoring research in the last decade and how these changes have enabled our community to grow exponentially. And I'm super excited to serve all of you in the audience today. I have prepared 2 parts of my talk. In the first part, I will attempt to map this vast landscape of refactoring. This is like thousands of refactoring research papers in the last decade. And you have not stayed up to date with refactoring research in the last decade, this is your chance to catch up. But if you're also from other communities, this will also give you ideas for your own community, how you can experience growth and how you can make a long-lasting practical impact with your own community. And also, I would like to maybe seed some ideas for new work that you can do and get some inspiration for new research that you can do. And in the second part of my talk, I asked Robert about the audience, and I learned that there are many students and junior faculty in the audience. In fact, I was just looking at the poll, and some of you are already filling it up, and I got a sense of who's with us today. And I prepare some of the lessons I've been learning in my career and in my personal life, and I really wished somebody shared this with me when I was a student or a junior faculty. And I want to take you behind the scenes. I'm so excited because I want to serve you by sharing about my journey, what I'm learning, and how I'm growing in my personal and professional life. So I understand my talk is about 45 minutes, right? And then we'll have like 10, 15 minutes at the end for Q&A. So with this, let's get us started. And I wanted to encourage you again. Lots of you have already participated in this quick poll, so about 40 responses. And I'm just looking at the responses on this quick poll. It just has 2 questions. If I was in a conference room with you, I would come to you, I would extend my hand and shake your hand and ask for your name. And I want to do that virtually through the webinar. So if you can see my extended hand, I'm shaking yours right now and I'm asking your name. And hey, my name is Danny and I'm here to serve you today and I would like to learn about you. So if you go to this poll, there are 2 questions. First, who are you? And those are the options that I gave. And I like that someone has said, a few people picked up other and they say, well, I'm a continuous learner. That's the best audience. People who are students and are continuing themselves. That's the most distinguished audience. And the second question that I have asked you is, how often do you refactor? And let me look at the results. Let's see what are we getting right now. So about 50 people already replied to this, and the numbers are going up as I'm speaking right now. Half of the audience, about like 54%, are software developers, testers, and users or practitioners. I'm so grateful for you. You guys make a huge difference. You make us all famous. We have about 10% managers. Then we have, let's see, undergrad and credit students. It's an equal mix. Looks like about 5-10% each. Professors and other academics, it's about 14%. And we have some teachers from high school, some lifetime learners, research scientists from industry, so quite a few people who selected other. So when I'm looking at how often do you refactor, I see that some of you, about, let's see, what's this number? About 5% said never. The vast majority selected sometimes. That's about 40%. And the remaining 30%, second largest category, it's people who refactor often. And then we have about close to 9% who almost always refactor, about 13% who rarely refactor. So it's a good mix of people at different stages. So this is good because it helps me to go through my slides and advance at a different delivery speed, and so that you'll get the most value. Good. So let's get started. So what is refactoring? I think many people were introduced to refactoring through the work of Ken Beck and Ward Cunningham from Extreme Programming and Agile Programming and Agile Methodologies. And then Martin Fowler's seminal book came up. And Martin Fowler is with us today online today. So I'm so grateful for your work, Martin. It has made a huge difference on our practice. So for me, refactoring was love at first sight. I fell in love with refactoring when I first read Martin Fowler's classic book on refactoring in 2000. I've been working on refactoring ever since. And this is Martin's definition of refactoring. So if you look at this definition, any software changes that we make to our programs, such as, I'm renaming a function that it's maybe has a cryptic name, or I'm broken a very large and complex function into more simpler functions that can understand me, they can use better. So those are all classic examples of refactorings. And if I was to ask you on the poll again, how many of you have done refactoring, I'm pretty sure the numbers will go up, because I think all of us who have done any extent of programming, we have renamed and changed our programs to make them easier to understand. So a couple of other books that have been extremely influential for my own development were this one, Refactoring to Patterns by Joshua Kerievsky, and Working Effectively with Legacy Code by Michael Feathers. And if you are on the line today with us, then I'm very grateful. Again, you've had a tremendous impact on my own professional development and on the field as well. Looking now on the industry, refactoring has made a big splash. It's a top-level menu in all modern IDEs. If you look on the top level, it's file, you have edit, and you have so on, and then you have refactor. And I was very fortunate to work on the world's first open source refactoring tool for Java. This was back in 2000. I released as a plugin for JEdit, and for 1 year, I thought that I could compete head-to-head with IntelliJ. It was a commercial refactoring tool from a great company, JetBrains, who have been doing fabulously well. But, you know, they beat me. You know, they had the company, the full team of dedicated people. So I learned early on a very important lesson that you need a team of people if you want to accomplish something of significance. So I no longer venture solo. I joined the Eclipse refactoring team about 2004, and I started to contribute to Eclipse IDE and then later on to other IDEs. But that's a lesson that I learned earlier on in my career. So let me talk a little bit about what has happened on the research side. On the academic side, refactoring research has seen a tremendous growth, as you can see in this graph. So on the horizontal line, I've tabulated the timeline from early 90s to about 2016, and oops, something is happening with my slides here. Okay, and on the vertical, it shows in every year how many peer-reviewed academic papers were on the topic of refactoring. So a couple of observations you can see from this graph. Interesting, it keeps going, it keeps advancing. Sorry, guys. It keeps jumping on its own, so I wonder if it automatically has some timing or. So as you can see on this graph, a couple of interesting observations. Refactoring research started about 10 years before we have seen the influence and the big take on in industry with Martin's book and also with the IDEs. And the second observation is that it was the appearance of Martin's book and the IDs that started to support refactoring that have seen a tremendous growth, almost exponential growth in refactoring. So the success of refactoring is because of this intertwined thread of industry and academic work. So let's talk a little bit about some of the humble beginnings of the field. And this is where I talk about the champions. This is where I talk about the pioneers of the field, and we stand on their shoulders. And I'm so grateful for all of these people. So the first published paper on the topic of refactoring appeared in 1990 at the University of Illinois. Was Bill Opdyke, and Ralph Johnson was my former PhD advisor. Most people probably will remember Ralph as one of the authors of the Design Patterns famous book. So this first research paper introduced refactoring as a way to extract reusable abstractions from existing applications and create frameworks. Now, if you look at other work that was happening concurrently, something is really funny. Okay, something is funny with these animations. Probably I should lesson learned. Get rid of animations probably next time when I'm doing a webinar. So refactoring was invented concurrently at an independent universities. This is way too frustrating to go. It's jumping at. Wow. So two universities, Bill Griswold and David Notkin at University of Washington, they were working on refactoring for functional programs in Scheme. At the same time, Ralph Johnson and Bill Opdyke at University of Illinois were working on refactoring for object-oriented frameworks. And Don Roberts, his PhD dissertation that was also at the University of Illinois was the first one to present an industrial strength refactoring tool for Smalltalk. He worked on this with John Brandt, who's an amazing tool builder. And their tool, which was called the Smalltalk Refactoring Browser, heavily influenced Martin Fowler, Ken Beck, and all the refactoring tools that follow later on. So at that time, I was looking for what are the active groups and places to do research in refactoring. So that's how I came to join Ralph Johnson's research group in 2002 for my own PhD work on refactoring. So I asked every single one of these pioneers what it looked like to do research in refactoring in the early 90s. And they all told me how hard it was to publish. The research community looked at refactoring and said, hey, you know, it looks like a lot like compiler transformations, but these transformations do not have the rigor and the guarantees and the formalism that the compiler community was expecting. So their papers kept getting rejected from the computer science community because just didn't fit in the mold. What they have gone, these pioneers have gone through the pain of getting so many rejected papers, but what they have done for all of us, they have paved the way, a new way of thinking about interactive program transformations that put the programmer in the loop. So I'm so grateful, so excited, so full of gratitude to this, walking on the footsteps of these giant trailblazers that walked ahead of us and opened the field for us. So let's look at what happened more recently. So after Martin Fowler's classical refactoring book, a lot more academics started to pay attention to refactoring. I was one of them. So the period that I want to focus is the one that I have selected here. It's the most recent decade, from 2005 to about 2016. And why is this interesting? First, there's an excellent survey by Tom Mans on what was the previous state of the art with refactoring research prior to 2004. And that's very widely cited and very well done. So lots of people have got a good glimpse of what has happened before 2004. It's a much less known what happened after 2004. Second, if you look at the number of papers, you'll see that more than 80% of all refactoring papers actually were published in the last decade. And this decade is very interesting because you see a rapid rise up to 2008, 2009, then some decline in the middle, and then an even more rapid growth, and the field has been growing. So, if you're sitting next to a colleague in a workplace, I just want to warn you that we are going to do now a tour de force on this about 2,400 research papers. So if you're sitting next to someone, just please turn to them and be nice and tell them, fasten your seatbelt, buckle up, because we are going to attempt to do at least a tour de force on all this work. So the corpus of papers that I'm going to describe, and this is the work that was collected by my collaborator Maroon Crescentini and his team at the University of Michigan. And simply, to be very honest, I was simply an advisor and a consultant to the project. I kept asking them questions and probing them to explore different parts of the data, but actually they are the ones who did all the digging. So credit is due where it needs to go. So when you heard me saying about this corpus that we did this and we did that, it really means, Maroon and his students at the University of Michigan. So we started by searching for the term refactoring in title, abstract, and keywords on all peer-reviewed papers. And this yielded about 3,200 papers. We looked at those papers that contained a definition of refactoring having to do with transformations that preserve the behavior. So all of these papers went through manual validation. So for each paper, the students read the title, the abstract, and sometimes even the content. These were 4 graduate students who took a graduate course on software quality assurance with Maroon Crescentini. And they independently voted whether this was a refactoring paper. And so I wonder if people, because my slides keep going back and forth, so I wonder if someone else can control my slides. If you logged in for any reason as a presenter, please stop advancing my slides, because somehow someone is controlling, it's advancing my slides, and it's not productive for me to go back and forth and to get us back to where we are. So going back to this, there were 4 graduate students who independently voted on whether this refactoring was a refactoring paper. If at least one of them said no, then Maroon Crescentini had to look at the paper himself. And in the end, we end up removing about 400 papers. So the ones that we end up leaving in the corpus are high-quality papers that have been thoroughly scrutinized by 4, in some cases even 5 individuals, and we are very confident that these are truly refactoring papers. So let's look at some of the, we looked at this corpus, and we studied, and we first asked the question, who is publishing actually? Who is doing all this work? So this graph that we show here, we look at the influence of the most prolific authors that they have in the community, and this is based on the citations of their refactoring papers. So I'm overlaying on this graph 2 data points. The blue bars here show the total number of citations for refactoring papers, and the orange line that is overlaid on the top shows the total number of refactoring papers that each of these authors have published in this last decade. And what I'm showing here is just the top 25 most prolific authors. There are close to 5,000 authors, so there's no way I can show all of them here. What you can see on the left-hand side, there are few authors like myself and Ralph Johnson who have both a high number of citations. So I have about 800 citations or so on those refactoring papers, and well, like 37 refactoring publications in that decade. And you can see these are both highly cited and also relatively high number of publications. These are fairly established researchers. Ralph Johnson is one of the pillars of the community. But what's also surprising to me from this chart, from this data source, and I highlight here some of the authors that you might recognize as being active in other communities, for example, in the generative programming, in the model-driven community. So people like Sven Appel and Christian Kastner and Don Batori and Kuhleman, they do a lot of work on refactoring for software product lines and models and generative programming. So the first observation that I want us to all take from this data is if you want to grow a community, you need to be welcoming to our champions and outsiders who are crossing from other communities. And the corollary is also if you are a champion from a community and going into another community, you can be very influential and very cited, despite not publishing a lot of papers. So if you look at Sven Appel or Christian Kastner, they have a relatively low number of papers on the topic of refactoring, yet those papers have been highly cited. Even more specifically, maybe more practical for the PhD students or junior students who are still looking to form their own PhD committees, I want you to be very intentional in inviting people from outside of your area so they can provide a fresh perspective and insights and can make your research more impactful. So second question that we studied using this corpus is, we looked at what has been the focus of the research in the last decade. So now what I'm showing on this graph on the horizontal axis, we again have the timeline of the last decade. On the vertical, we have the number of papers that were published along different lines of focus in this last decade. And the original focus on refactoring was on automating the analysis and transformations for refactoring. And as you can see, most of the research that is still done today is still about automating analysis and transformations. Second, if you look at second most prolific line of research is to gain insight where in the code do we need to introduce refactoring. And in the beginning, the refactoring community, we were thinking more like the insight comes solely and only from the domain, from the mind of the programmer who has the domain knowledge. But now the community is turning around and is seeing that actually we need to be working on generating this insight. And it makes sense because a lot of developers are working on code that was written by other developers who left long ago, left the company. So these new developers need to gain new insight about which parts of the code need refactoring. So it makes a lot of sense that we have seen a lot of growth in generating recommendation insight for where we should apply refactoring. Another area of great focus in the last decade has been testing the correctness of the transformations of the refactoring tool. So there are conferences like the International Conference on Software Testing, just a couple of years, had 4 papers on testing the correctness of refactoring tools. And this makes sense because increasing the trust in the refactoring tools, this is one of the most, when people in the industry talk about the cost or barriers for adopting refactoring tools, they talk about the cost of ensuring that this transformation is correct and it's done consistently. So I'm very happy to see that lots of people in our community have been working on making the refactoring tools more robust. And prioritization is another line that has been very active in the last decade. Scheduling, this is about scheduling refactoring opportunities. So when programmers receive hundreds of recommendations from a research tool, prioritization becomes very important. They cannot apply all hundreds of recommendations. And this growth spur in the field, it's correlated with a lot of growth in other fields, such as the technical dev community and the workshops that appeared in the last decade along those themes. Inference is the last one that I want to talk about. These are tools for automatic detection of refactoring activities that already took place in the code. And again, this is very important for understanding the evolution of the code, for program comprehension, and many more other applications. So what I want to do next is I just want to give you a couple of examples of transformations and how the community has been growing in the area of automating new kinds of transformations and in the area of inferring refactorings. And here I'm going to use some examples from my own work and some of our collaborators. So much of the work on automating refactoring has moved by now way beyond a rename method and rename class and extract method. So now we have ever more increasing complex, more sophisticated refactorings. My own research group has developed refactorings for introducing functional constructs in existing object-oriented programs. And the ones that we've done, for example, in Java was to replace the imperative style of iterating over loops with the functional style of using functional streams such as map and filter and reduce and apply and passing lambda expressions. So we were fortunate to collaborate and to work with the developers of the NetBeans IDE. So now these refactorings have been shipping by a few years now with official release of the NetBeans IDE. So in the area of support for automation, we have seen a whole new emphasis on scalability. So for example, together with my collaborator, Don Batori from UT Austin and his students, we developed higher level refactorings that introduce design patterns transformations, sometimes consisting of hundreds of lower level refactorings such as move method. Yet the techniques that we designed and we developed, empirically we evaluated them and we showed that these are about like 10 times faster than the state-of-the-art IDE refactorings. And this is important for doing those larger scale refactorings that are going to involve many refactoring steps. This was a step in the right direction, but I think we are just at the cusp of a new breed of refactoring tools and new automation that it's more adept to tackle the challenges of today's gigantic code bases. So for example, we are currently working with software engineers at Google, and their unique challenge is that the code base is in the order of hundreds of millions of lines of code. The code base is so large that it cannot fit in any IDE in any single computer, so they don't even try to do that. They keep it in the cloud. And we are automating with them refactorings that replace a certain type, let's call it type T, with a type R, and we want to do this consistently across the whole code base. For example, we want to replace usages of hash map, let's say with array map, just to improve runtime performance. So the current generation of refactoring tools require to load in memory the whole code base to analyze, which of course is not feasible to do at a company of this scale. And moreover, the current generation of refactoring tools are dependent on the IDEs. They do not fit with the modern workflow of continuous integration and tools that build and involve different analyzers and checkers continuously. So that's why I accepted the challenge, and together with them, we are developing the next generation of refactoring tools that are using a different metaphor, global distributed refactoring. So we are doing this via MapReduce on the cloud, and our empirical evaluation shows that we can do these global refactorings across hundreds of millions of lines of code in just a matter of 50 minutes. We generated hundreds of refactoring patches that were accepted by developers, so this shows that they are useful. So a second example of how the focus has shifted in our field, I want to give some examples of inferring refactoring that already took place. And this area is important because it's important for understanding the code evolution, for understanding program comprehension. There are many more applications such as supporting code merging, code reviews. One of the tools that I released a few years ago with my own group was inferring API-level refactorings for doing library migration. Refactoring inference has also been very active line of research. Maybe Reffinder is one of the more well-known tools from out there. So it's from Miriam Kim's group at UCLA. And it's one of the most used tools in research. It infers probably one of the most comprehensive list of refactorings from Martin Fowler's catalog. But I want to say that this line of inferring refactorings maybe has stifled in the last 4 or 5 years until it was reinvigorated recently by a new breed of tools that address limitations with the previous generation of tools along the lines of significantly improving accuracy and also making it easier for users to use. It doesn't require any user thresholds. So Refactoring Miner was developed by the group of our collaborator Nikos Tsansalis from University of Concordia. It works at a much finer grain. Takes as input consecutive commits, so it's much more precise than the previous generation of tools that took as input entire new versions of major milestones or releases of a project. So this works at a much finer grain. So that's why it's significantly more higher accuracy. It does not require also users to fiddle with any threshold. So it's much user-friendly than the previous generation of tools. It's the new state-of-the-art, significantly improves accuracy, and it's ultra-fast. It's on average takes about 50 milliseconds to identify refactorings for a commit. So we are excited because it can be used with continuous integration tools. Every time when a user commits the code, you can have you can invoke the APIs of our tool and can on the fly infer the refactorings that were part of that commit. So I'm very excited to announce that also we released the largest and most trustworthy data set of about 3,000 refactorings. These are from real-world projects. Other researchers can use to validate their research. People in industry can use these real-world examples in the real-world code to educate themselves. So here I have the link where you can find this corpus. Okay, so going back to the trends in our big corpus of 2,400 refactoring research papers, we asked the question, what is the target of the new refactoring tools? So the original target of refactoring has been on targeting code, but other researchers have targeted other artifacts such as models, architectural refactoring, databases, refactoring the user interfaces. And it's surprising actually to see that in the last decade, if you look just in the last few years, in the last 3, 4, 5 years, refactoring for models actually has even surpassed refactoring code. And some of the very active people in this area, like Gabriel Tanzer from Germany, she's one of the people we saw earlier on the previous slides of Impactful People. So lots of room to grow for other targets. For example, now everyone talks about we are in the big data era. A new direction could be refactoring for data, and this is what I expect to see a lot of growth. The next question we ask, why do people refactor nowadays? So original motivation was to improve the internal code quality. We have seen huge growth in other objectives. So it's very surprising. If you look at this, starting with about 2000, you see performance was the main target, even more than refactoring that improved the internal quality of code. And many people in the industry mentioned that the main goal for refactoring is to improve performance. Research community probably realized that this is more marketable, performance is more marketable. You can say, hey, I can make a change that might improve the maintainability of your software in a few years, but if I can I measure this now? So in contrast with performance, this is quantifiable, has an immediate measurable impact for end users. So it's somehow not surprising that we have seen a lot of people work on the refactoring for improving performance. Lots of new work on other areas. What I like to see more, it's refactoring on security. Can we have security preservation? For example, when I integrate modules in an autonomous vehicle, can we still preserve the security constraints, not only the behavior of the program? And this is where I think that the field is going to grow a lot more as we move forward. So looking at just again some examples of refactorings for performance from my own research group. So if you think about mobile and performance in mobile, today, actually this year, Gartner predicted there will be more than 300 billion apps that will be downloaded on mobile platforms. However, all these mobile devices have limited resources. They make excessive network calls. So it's very easy for a mobile app to freeze and to become unresponsive. And that's what one of the famous research papers found recently. It's one of the leading causes for performance bugs, the majority of performance bugs in Android. So the main culprit is long-running operations, which run in the main UI thread and block the UI thread, so it cannot respond to other user activities. The solution is to refactor the code to push these long-running operations asynchronously in other threads, call back into the main thread with the result of the computation. However, refactoring from synchronous to an asynchronous model, it's non-trivial. Refactoring is to preserve the original program behavior, the thread semantics, even the order in which exceptions are found. And even once arrived in the promised land of async programming, the app developers still need further refactoring, for example, to replace a legacy style of callbacks, asynchrony with more modern styles of async and await, like the ones that were introduced by C#, improving performance of asynchronous code and so forth. So along these vectors of refactorings, we have been automating some for Android, some for .NET, and some for Java and C#. And surely, there's a lot more work that can happen here. I just want to skip over this work that we've done with refactorings for parallelism, for multi-threading in the interest of time. So let me go to the next slide. The next question that we ask out of this big data is, how do we know that our tools are useful? How do we know that our research works in practice? So the vast majority of people in the refactoring community have employed empirical evaluation as opposed to using an analytical evaluation with proofs of correctness. And a lot of these papers that use empirical evaluation use open source data, which means that they apply the tool on some open source project. Maybe they replicate some refactorings that were done by open source developers on that project. Maybe they send some patches to the open source developers. But I'm very excited to see an increasing number of refactoring papers that involve industrial collaboration, where industry collaborators have applied the tool, gave feedback. The code is used by industrial partners, maybe with sub-licensing or with any other agreements they have in place. And this is much, much harder to do, to bring business value to the company. The researcher must actually go the extra mile to work harder. But I think this is one of the greatest potential for changing the world of software development. And just a couple of months ago, we've been deploying one of our tools, as I mentioned earlier, inside Google. We performed these large-scale refactorings across the whole Google code base. And I must say, it was one of the most rewarding experiences of my academic career. I also have a call for action. So if you are someone from industry, please be kind to academic researchers. Invite them to talk about their work. Invite them to give demos about their tools. Be willing to try their tools and give feedback. And we truly appreciate you. And these interactions are extremely valuable for us. It's your honest feedback about what works and especially what doesn't work that makes us better, that makes us stronger, and helps us to create the tools that eventually make you more productive in industry. So wrapping up this part of my presentation, we have seen a significant expansion of the field of refactoring, and it's because we simply refactor the definition of refactoring. So we have truly eaten our own dog food. So we are people who believe in refactoring to the point that we refactor ourselves. So we've seen a tremendous growth and expansion because we moved beyond with the focus, with the objectives, the techniques that we use. It's beyond the original work, and now refactoring is about automation. It's about generating insight, testing, prioritizing, changing changes that appear not only to the code but many other artifacts. And the goal is no longer only to improve non-functional internal quality, but many other non-functional requirements such as performance, security, and even without changing the definition of behavior preservation has slightly changed. So preservation of behaviors has expanded to mean that we want to preserve the proper intended behavior, but they want to remove the improper behavior. For example, a security refactoring will eliminate security exploits, hackable behavior. A performance refactoring will eliminate sluggishness and slow responding code. So the behavior has been improving in a manner which is consistent as desired. So as a corollary, the big lesson from this journey is that communities that thrive are going to be more accepting of new ideas from others, and that's what we have seen as becoming one of the greatest catalysts for growth in our community. So I just want to add one more slide before we move to a different part of my topic. Significant expansion came because of understanding the social part of community engineering, contributed to the growth and impact of the field. So it was key to attract strong industry champions such as Martin Fowler and Ken Beck and Ward Cunningham and Joshua Kireski and other people who are very active in the Agile community. Very grateful for you. You've been spreading and talking about refactorings in your circles of influence, and this has made a huge difference. Most people, another lesson is that most people in the academic community are very good at publishing papers. So we need to partner with people that have complementary skills that are great tool builders. And we've seen this over and over with the big successes in our community. So Don Roberts, that was partnering with John Brandt on the Smalltalk refactoring browser. If you look in the Eclipse team, you have Frank Tip from IBM Research was more on the academic research, partnering with the Eclipse Java development tools led by Eric Gama at IBM Zurich. So great partnerships, and we created a nice ecosystem of researchers that were supporting the industry and vice versa. So we were all helping each other. Another lesson that I think has been hugely contributed to the growth of our field is the mindset of people in our field to proactively seek industrial collaborations. Getting honest feedback is usually painful to accept, but it's this pain that makes us grow stronger and do better. So having a shared platform of doing program analysis that we can all build upon as a community. So we adopted Eclipse. It was open source. But it was open source, looked like, professional industrial strength quality with yearly major releases. It was backed up by IBM. The documentation was so-so, should I say. But Eclipse had made up for that, had great developer support forums. Researchers could learn from reading the source code of refactoring plugins. Then there were a bunch of other analysis infrastructures like Walla and Suit and others that we have been building upon in our community. In terms of community infrastructure, we have been organizing the first refactoring workshops. I was the organizer of the first 4 refactoring workshops. I remember the first one in 2007 at eCoop. We had about 50 participants. 32 of them presented posters, and we had a big display of all these 32 refactoring posters in the main hallways at eCoop. So it turned out about 2/3 of the eCoop posters that year was on refactoring. So everyone was walking around the hallways at eCoop and say, hey, what's up with this refactoring, guys? Everyone seems to be working on refactoring nowadays. So, but also going with refactoring workshops. So we were intentional to invite all the IDE providers. So all the major builders, the Eclipse, NetBeans, the IntelliJ, the Visual Studio guys, they came, they gave demo. That was crucial for our community, for the researchers to meet these industry people, to learn about maybe the undocumented features that they need to use, exchange best practices and tips and tricks and all the other things that are less documented. So I was one of in charge of the first 4 refactoring workshops, but I realized that I needed to attract new leaders and make room for others to get involved in leadership. So this is what we must do if we want to grow the field. We want to have other people, we want to have people with new ideas, with different backgrounds coming and taking a leadership role. And this is what led to significant success of our field. So second part of my talk, I'm just looking at the time. Robert, how are we doing with the time?
About 7 minutes left.
7, okay, so Robert just gave me another 15 minutes. No, I'm kidding. 7 minutes, okay, so I'll try to go faster. This is what I want to share, some of the lessons that I have been learning, reflections and lessons I've been learning in my career, and I wish that somebody told me this a while ago when I started, and I want to share this with you because students and junior faculty on this webinar, you can go further than I did. You can reach higher than I did. You can be get even more impact than the ones that I have been blessed and fortunate to have. So I will give you unprecedented access to behind the curtain information on how I do research, on how I approach research. Some of these insights are brand new insights that I have never shared before, and I'm so excited to serve you with some of these lessons. So why I'm doing this? On August 5th, 2015, I opened up my eyes just to find myself in a hospital. I realized that I had no clue how I got there. And I asked the nurse how I got there, and she said that I had a bicycle crash in which I lost my short-term memory. Of course, I didn't remember that. I didn't remember any bicycle crash. I didn't remember how many children I had or where I was living. I thought that I was still a faculty at the University of Illinois. And it was the weeks and months of brain recovery that it helped me to actually look at my life and to analyze my life. And while my brain was foggy from the short-term memory, I had the clearest, the best clarity of my life and seeing the whole big picture. And I saw that I was selfish, that I was maybe arrogant. I was successful academically, but I was probably too selfish. So I wanted to turn my life around. I decided it was time now for me to serve people instead of waiting to be served by others. So every day I'm learning how I can intentionally serve people, how I can add value to others, and that's why maybe you don't see these sort of lessons in other people's presentation, but this is a priority for me now. So one of the first lessons that has been probably the biggest contributors to my success is that many times people tell you that you need to be good at everything, which is the truth is it cannot be further away. You cannot be an expert on everything. You need to know a little bit about everything so that you can make some connections and see connections. But focus on some of the areas that you are excited about and you are good at, and I call this the strength zone. And spend most of your time and energy in that area. Don't even try to be good at everything because you're not going to be. Rather, partner with others in your areas of weaknesses so that their areas of strengths complement your areas of weaknesses. So my personal story with refactoring, in the first 5 or 6 years of my PhD work, I have been working on the area of library upgrades to upgrade applications to use refactored APIs from new versions of libraries. Then, just as I was finishing this, the world turned around, parallelism and concurrency. Intel stopped making single-core processors. Everything was going to be now multi-core from now on. So I started to go even deeper into program analysis for concurrency and parallelism. And just as I was getting settled and I was getting more comfortable and getting more results in this field, there was another big shift with mobile. So the generation of my parents and grandparents and most end users that you see out there are spending significantly more time on mobile devices, on smartphones and the tablets than on regular desktop. So I've been started, the last 5 years I've been looking in how can we make mobile apps more responsive, improving the responsiveness of effectiveness for asynchrony. And now I'm getting slowly into another area of if you look at what's really coming next as the next big revolution in computing, it's with IoT, having the digitalization of the world around us, how all these sensors are going to collect information about us, how the world with this augmented intelligence will augment our own human intelligence. So in this new paradigm, we see a lot more software and a lot more emphasis on using machine learning and using other forms of probabilistic computing to augment and maybe to work at some point hand in hand and then eventually to replace some of the deterministic computing. So from a refactoring perspective is how can we refactor existing programs that use deterministic algorithms to use more probabilistic computation, more machine learning and continuously learn. So this is yet another area. So some of the key lessons that I learned is many times when I venture and I try to be go into other areas like into human-computer interaction or compilers, Those were weaknesses for me, and I kept failing over and over until I learned that I need to partner with others who were strong in those areas in which I was weak. And I decided to stay and work in my core competency area, which was principles for refactoring programs between significantly different programming models, like going from sequential to parallel, going from synchronous to asynchronous, from shared memory to distributed memory. And at the same time, I kept an eye open on the big changes that were happening in the field of computing. I'm reinventing myself roughly every 5 years. I go into a new big area, but I stay in my strength zone in what I'm good at. And going into a new area, it helps me to stay fresh, to keep learning, and to keep improving. Finding your dream and then live it. So this is another huge thing for me. It's you really know what you really want. So for me, do you want to publish papers? That's good. Do you want to have lots of citations? That's great too. But my dream is for making a practical difference in the field of software developers. So I was fortunate to work on several refactorings that ship with official release of Eclipse and other NetBeans and Visual Studio and other IDEs, and to have work that has been used at all the major software companies, and to work on understanding how people use concurrent libraries and frameworks, and to have an impact that has shaped our understanding and shaped official APIs of concurrent libraries in .NET and in Java. And why I'm saying this all, I'm not saying to impress you, but to impress upon you this principle that it takes some mindset and dedication to identify what's your dream and to pursue it. And none of these adoptions would have happened by chance, but just publishing papers and wishfully hoping that someone would pick them up one day. I was proactively pursuing industrial collaborations and working with industry, and you have to think about what you ultimately care about, and you have to go after it. So I want to skip over this next one on being proactively looking for opportunities to work with industry, but being flexible. The last part I want to talk about, and I would say probably this is one of the most important ones. So a major theme in my talk today has been about growth. How do we grow the community? But how do we grow? We need to first grow ourselves before we can grow professionally. Before we can experience and sustain growth on the outside, we need to grow on the inside. We need to first grow ourselves before we grow our teams. And if you've been recently on a flight, you might remember the flight attendants announcing over the speaker before just the plane takes off. They say, hey, first put on your oxygen mask before assisting other passengers. Why do they say that? Because you cannot help others if you have not helped yourself. You cannot give what you don't have. So I used to believe that I will automatically grow through experience, and I'm discovering now that experience is not the best teacher. Some of us just go through life, other people grow through life. So I'm surrounding myself with a group of other like-minded professors who are intentionally dedicated to grow ourselves, and we have a weekly roundtable discussions. We are intentionally studying with each other how to become a better person, a better mentor for our students, a better parent, a better spouse. So just this last week, we were discussing about character, and while it was very tempting to shift the discussion and to talk about the character or lack of character in our students, I say, well, let's talk about us. And the weekly challenge that we had was to interview 3 people that know us very well and to let them speak into the gaps they see between who we say that we are and who we truly are. So I asked my wife, she knows me very well, probably she knows me better than I know myself. And it was a mind-opening to see the gap from her viewpoint of what I think that I'm a leader for the children in the home, for my family, and how in the last few months my wife told me that I got more sidetracked as I'm building up and ramping up a new industry university research consortium with more than 60 companies and with the National Science Foundation, and how I had an insane travel to industry and how I was neglecting and the family felt they are less of priority for me. And it was painful to hear this, but it's this pain that causes growth. And it was this accountability of the group that help us to stay accountable, and we are learning and we are growing together. So I really wish that I knew this earlier in my career. I wish that somebody had a group like this when I was a student, or a junior faculty, I think I would have been significantly further away. I can't imagine where I would have been if I started this 15 years ago. So I want to finish with my most important investment is the people that I've been very fortunate, the students I've been very fortunate to learn from. Probably I learn more from them than they learn from me. And I want to end with the call to action. We've seen a big growth in our community because of refactoring or reinventing ourselves. This is good news. The field keeps growing. As long as there is software change, we will stay in business. I've also shared with you some of the personal lessons from my career. And I want to end with a call to action. So I recently came from a vacation in the Glacier National Park, and I was doing some long and epic and strenuous hikes together with two of my friends. And I was reminded of a proverb that if you want to go fast in life, then go alone. If you want to go far, then you can go with others. So I'm looking forward to partner with you, to go together with you. Together we can go much further than we can go on our own. And I would like to start a dialogue with you. If you are from industry and you have some code bases where you need to replace deterministic with non-deterministic computation, please contact me. If you are a manager or an industrial practitioner and want to have more answer to more questions about the state of practice of refactoring, we are doing a large-scale empirical study of hundreds of thousands of open source projects that are using refactoring. So let me know what you're curious to know about that, and we can do this research for you. Also, if you need ideas on how to find your own group of like-minded peers that you can learn from, please contact me. I'll be able to share some of my own ideas. And finally, I greatly appreciate you for looks like my slides are advancing again on me. Greatly appreciate you and your feedback on today's presentation. So as soon as we are over, please jump on the email and let me know what are the parts that you found the most valuable, or maybe you have contrarian points, and I will send an anonymous survey so you can tell me what was the most valuable points. And ACM respects your privacy. There is no way for me to know who you are unless you contact me. So I really appreciate as soon as we hang up, please email me because I want to be totally in tune with what you experienced today. With this, I want to thank you so much. Thank you, Robert, for asking me to be on this call and hosting us, and I think it's time to take some questions.
All right, thank you, Danny. I think we actually have time for just one question. So green code is kind of a hot topic these days. Do you have any thoughts on how refactoring can help improve energy efficiency?
It's really hot, and it's hot for oops. Something is happening again with my slides. So refactoring in the area of utilizing energy efficiency is becoming more and more important for mobile, especially for IoT systems that are going to sense a lot of the world. There has been some work by others. Look in the proceedings of the Conference on Mobile Software Development, so MobiSoft. There's been a couple of years of work done from people in Singapore, and there are other people who are jumping on this area. That's a crucially important area nowadays, and I'm happy to see other people working on it. That's a great question. Do you have another one?
Well, unfortunately, I think we've actually run out of time. So thanks again to Danny for his informative presentation and his insightful answer. I'd like to give a special thanks to each of you for taking the time to attend and participate in today's webinar. This webinar was recorded and will be available online in a few days at www.sigsoft.org/resources/webinars.html. You can find announcements on upcoming ACM and SIGSOFT webinars and other ACM activities at learning.acm.org and www.sigsoft.org. On behalf of SIGSOFT, the speaker, and myself, thanks again for joining us, and I hope to see you again in the future. This concludes today's webinar.